主要是 Google 的那个 solution， 然后他来跟我们分享一段 Dataprep 的部分。那我们接下来欢迎他来跟我们分享这个 session。
Hi, maybe some of you saw me yesterday. You have. Hello again if you haven't. Hi. So, I'm a solution architect in Google Cloud. I'm based in Singapore, but I handle the Asia Pacific region, and I absolutely love Taiwan, and it's really fun to be here again and see all of you. Anyway, let's get to my presentation. So, I would like to talk about Cloud Dataprep, or how I personally think of it, easy data flow. Yes, it's like the missing user interface for data flow, to be honest. So today I'd like to show you a live demo of Cloud Dataprep and also talk about data flow a little bit. So why Google and data? You may have seen this already, but we have quite a lot of customers. We have 8 products with more than 1 billion users. Now you're thinking there's 7 billion in the planet and you say you have 8 billion, it doesn't work. Well, some people use more than one product. But anyway, you get the idea. There's massive number of users in the Google platform. Probably the biggest anywhere. So Google engineers had to basically invent the technology to build Google. And Google Cloud is Google. That's the beautiful thing. So what I also love about Google is that Google is quite open about what it does and why. So as the Google engineers solve these amazing planetary scale data problems or IT problems, they open source them. They publish them as white papers. You know, TensorFlow and Kubernetes and all these are open sourced by Google. So when it comes to data, there's a lot of innovations that Google engineers did already many years ago, but they actually published those as research white papers. The first one is GFS, Global File System, or Google File System, basically making the entire planet, all the devices in Google data centers as one file system. And then there was MapReduce, the idea of programming paradigm of splitting a job into many different pieces, distributing those to many workers, and then collecting the results again. Well, you may know that these 2 white papers inspired Hadoop. So Hadoop was born out of those 2 Google white papers. Hadoop is good, but it has some issues. You have to transfer data to computing and then transfer the data out again, so there's too much transferring of data back and forth. That's why Google doesn't really use Hadoop anymore. We made something else, and that's something I will show you today. Moving on, 2006, we released the Bigtable white paper. Bigtable is where we have a copy of the internet. Yes. When you think about Google search, it has to be able to know what is there in the World Wide Web. So Google keeps downloading the rest of the internet and then indexing it. You have to store it and index it and give it as search results in milliseconds to customers. Where do you keep a copy of the internet? Well, they make Bigtable, which is a really large scale and deterministically fast key value store, no SQL data store. Deterministically fast means that it's always the same speed and it scales absolutely horizontally forever. Okay, and then at some point Google became more of a product company. We started to have actual products and customers. With those came things like product managers. Product managers want to know how many customers they have and who are the customers, etc. They need data analytics, they need reporting, they need business intelligence, they needed a data warehouse. Just like with the other things, Google's scale was too big, so nobody could buy a data warehouse that can handle Google data. So they built one again. They built something called Dremel. And interestingly then, if I switch to the next slide, oh no I don't have that. This became BigQuery. So Dremel became BigQuery. And BigQuery is a Google Cloud data warehouse service. After that, we then replaced our file system with Colossus. So today, Practically any data you store in Google, doesn't matter what service you use, it goes to Colossus. So Colossus is Google's planetary file system. At the end of the day, all the data is stored in Colossus. The other things like databases and whatever, data warehouses, are just representations and services on top of Colossus. But Colossus is the raw storage itself. And then most of the other things here are actually related to real-time data handling and real-time data processing. Hadoop is good and everything, but it's too slow. It's too slow, especially at Google scale. And in general, you want to go to real-time processing because then you can act in real time. Let's say that you are analyzing your customer satisfaction, your customer experience. You're analyzing your customer experience. If you can analyze it while they are still connected to your system, you can affect your customer experience online when they are still connected. For that you need real-time analytics. So that's when data flow is then born. What is data flow? There. Data flow, and in general, the Google Cloud's data services are all born out of the Google internal innovations that I was talking about. So, that's fine, but what do you actually need to do? I was showing you technology, I was showing you things like storage and data warehouse and NoSQL data store, and I was talking about real-time analytics. That's fine for geeks like me who love technology, but real people in the real world actually have business problems. You need to do something valuable, not just play with technology. So what you need to do often as a data engineer is to go from raw data to actionable insights and reports. So basically what happens is that your manager usually will say, we have these new log files, I want to have a report that shows our top 10 customers and whatever segmentation. Okay, so you go from raw data that is usually broken and a bit bad and it's all over the place into a beautiful management report that can drive business decisions. So data engineering happens in the middle. And to make that easier, I mentioned that Google doesn't really use Hadoop anymore. We built something that we now call Dataflow. And we open source that in the Apache Foundation as Beam. So Google open source Dataflow as Apache Beam. And there's two things there. There's the programming model, an SDK, Beam itself, and then there's the managed service called Dataflow, which is an option. So, first of all, what is Beam? It's a unified way to handle both batch processing, so files, and streaming, real-time processing, in the same pipeline. You no longer have to have two pipelines, one for files, one for batch, and another one for streaming. Then you collect the results, and they don't agree. And you have two systems. Having two systems is bad anyway, because you have to buy and maintain and support and upgrade, whatever, configure two systems. It's just double the effort, at least, maybe 3 times the effort, compared to having one system. So that's good. If you want to run Apache Beam, which is the open source programming model, you can run it in many different places. You can run it on your laptop, at least for development and testing. You can run it on Apache Spark. If you want to run Beam pipelines, in Google Cloud, we have the service called Dataflow. So Dataflow is the service that automates running Beam pipelines very easily for you. So Beam means batch and stream. So that's like the joke in the name, batch and stream in the same pipeline. That is an Apache open source project. Very popular. And Cloud Dataflow is a service to run Beam pipelines, if you want to run them in Google Cloud. Why is Dataflow good? Because it's fully managed. If you think of services like App Engine, It's really nice because it's beautiful for the users. You just have code, your app, and you tell App Engine, run it. Just do it. I don't care whatever load balancers, servers, I don't care. Just do it. Just run it. So you go from code to production. Think of data flow in a similar way. You have a pipeline that you want to run for your maybe stream processing. You just say, just run it for me. I don't care how you do it. So that's a managed service. So it does a lot of things like, of course, high availability, reliability of your pipeline, monitoring, logging, automatic healing, self-healing if something goes wrong, and then of course scheduling your work. So if you want to run a beam pipeline, it means you want to do some big data processing, or at least data processing. Not be big, but maybe it will grow. If your data processing pipeline grows to much bigger, you don't have to re-engineer your system because data flow can scale forever. It scales horizontally. It can help you with autoscaler, so you can just enable autoscaling, bling, and then it will automatically resize your infrastructure. You don't have to worry about to have enough horsepower to run your pipeline. But it's a bit more intelligent than that. It's just not just a number of nodes, it also understands your pipeline and it can shuffle your work elements around, your graph nodes. So this is autoscaling. So you start running your pipeline with data flow. Let's say first it starts with something like 12 nodes, but that's not enough. You start lagging behind real time. The system knows how long your processing takes. And it can tell you all the time, you're now 7 seconds behind real time, you're now 2 minutes behind real time, so you're dropping back, right? Not enough horsepower. Data flow can then add more nodes. And everything is parallelizable. Is that a word? So in the pipeline you define, all the steps in your pipeline have to be such that they can be allocated to multiple nodes. So then data flow can just add more nodes and your pipeline gets faster. It's lagging behind less. And then of course, if your traffic goes smaller again, it can help you save money and shrink your pipeline infrastructure. It does more things than that. It can also dynamically rebalance your job in mid-job. So you may have some transformations that take more time. What is a transformation? When you do data processing, you are doing things like maybe fixing broken lines or removing broken data entries. Maybe you do some aggregation, maybe group by key. You calculate minimum, average, maximum, whatever. Those are all transformations where you look at the data coming in and you have a step, it's called a transform, and the step does something. Like calculate average value in a time window, for example. So some of those transformations might be a lot heavier and a lot slower than some of the other ones. And the slow one, it may be slowing down all the other steps. You have a cumulative effect. Data flow is smart enough to reshuffle your transformation so that it avoids these hotspots, these slow spots in your graph. Okay, what do you actually need to do? That's all good though. I was showing you the engine room of data flow. I was showing you again engineering. You don't care. What you actually need to do is do your job. Get your data from somewhere, your raw data, and make it actionable. Maybe put it in a beautiful, structured, clean format in a data warehouse so that your manager can create his monthly report or daily report. That data engineering, that data cleanup, can take a lot of time. There are some reports that say up to 80% of data engineers' work is the horrible cleanup. The worst scenario is that you write some scripts to clean the data. Tomorrow you write another script because every time you get new data, it's broken in a different way. So you keep writing these little scripts that you use once. Even though it may be fun, it's kind of a waste of time. So what you need to do is you go from raw data, you explore what data you have. Well, these are the files your manager gives you. There's the data. like you need to clean it. Every data is usually broken. There are some log files, entries are broken, you need to remove those. Maybe you can structure the data, maybe you can go from unstructured, very messy data to very clean and structured data, if you want to put the data in a relational database or data warehouse, then it has to be structured. If you're okay with it being messy and sometimes missing some data, then you put it in a NoSQL data. That doesn't have a strict schema. You can also enrich the data, so you can basically join two different pieces of data, and maybe together they have more value. You validate that the steps that you have done look okay, and then you run it. But actually, you should run this data cycle more than once. You should be able to iterate on your data pipeline the same way you are iterating on your application code. You know it. You don't do it once. You keep fixing the bugs and you keep making new features, code, agile sprints maybe. You should be able to do the same sprints for your data engineering as well. Improve your data, because then the data is the one that can be your product, or it can drive your business decision making. The better data you have, you are happier. So that's where we launched this service called Cloud Dataprep, to avoid you, so that you don't have to script these little scripts every day that you use once, to make your life easier. So it has a nice graphical user interface. I will show you a live demo. It's built on top of Cloud Dataflow, but you don't have to code Dataflow pipelines. You don't have to code Apache Beam. It's like a user interface on top of Dataflow. You can have multiple different data sources and file types as the input data, and then you can, for example, output your clean data into BigQuery, or as files if you prefer, but there's probably more value outputting the clean data into BigQuery, because then you can more easily use the data from BigQuery. You can connect things like Tableau or machine learning models, whatever, into BigQuery. And it's quite a smart tool, because what you do with Dataprep is that it gives you recommendations. Based on your data, maybe you could do this. And those recommendations are based on machine learning, so they make your life easier. It looks like this. You want to have your data in BigQuery, our data warehouse. You start with some messy files in cloud storage. And then instead of coding some scripts to do this, you just start Cloud Dataflow. You get a nice user interface. I will show you next. You click, do stuff there. You basically create the Dataflow pipeline graphically with a graphical user interface. Then you say go. That will spin up a new Dataflow pipeline. Dataflow then does the execution and exports the clean data, writes it into BigQuery. So let's take a look at that. Let's have a live demo. I need to sit here for that. Just a second. All right. So here we have the Cloud Dataprep console. So first of all, if you can see the URL, it's https://clouddataprep.com. Of course, you can find it also from the Cloud console. But here we are. So everything here in Cloud Dataprep has a flow. So let's create a new flow. You get a new task from your managers. And let's call this Taiwan user group. Okay, so I create a new flow. There we go. First you need to tell the system, where is my data? So let's click Add Datasets. The easiest way to have data is to just dump it in cloud storage, GCS, Google Cloud Storage, our object store. If you haven't done it yet, you can import it in. I have already imported, so I will use this particular file in GCS. You can of course also point the system to a directory, which is full of files. Then the system will execute the same steps on all those files. So either you select files directly, or you select directories, and it will go through all of those then. So basically you just select your source files and you click add. Here we go. So now we start this wizard then. So we have the source files, we have only one file here, but actually it's not a very simple file. If you look at the preview window on the right, you may see that it's actually JSON objects. So it's not a CSV file, it contains JSON objects, and actually it contains multiple embedded JSON objects. There's arrays of information, so there's JSON objects inside other JSON objects. That's something that would be difficult for you. You would need to do a bit of coding to unnest, to open those JSON objects. Why do you need to open the JSON object? Because, for example, if you want to have your data in BigQuery or in a data warehouse in general, they expect rows and columns. They expect normal database tables. JSON is not natively something you can dump into a relational database. Okay, so we have slightly complex data here. You can see it's in GCS. And then what we do is that we click Add Recipe. Everything in Dataprep is done with a recipe. And then we click Edit Recipe. And what happens now is that the system is loading a 10 megabyte example of your data. In practice, it's loading the first 10 megabytes. If you know that your data is somehow a bit funny in the beginning, you can randomize it. Then the system will take another sample of 10 megabytes somewhere else in your file. So here we are. We have loaded this example, initial sample of our data into Dataprep, and we can see that there are some rows and columns. There's 6 columns currently, and 3,400 rows in this sample. And you can see that we have some things like a histogram here. So in this particular column, the system is already giving us some information. It's able to show us a histogram of the data values. You can also click on this little button here and select column details. And you can actually start getting statistics already. You see a much better histogram here. You have standard deviation, average, some quartiles. You have outliers that don't fit into a normal curve here. And then something green here. There's a green bar, and you can see that the green bar is everywhere here. Green means that we have good values on those different cells. Black bars would mean missing values. So there's nothing there, and that some cells would be empty. Red bar would mean broken values. What is a broken value? For example, a string in an integer field. If everything else is integer, 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 and then a string, that string is obviously broken, it's wrong. Wrong data type. Okay, you start to get an idea of your data by looking around here. Then we notice here in the sales order lines column that something is funny. We can see that it contains some JSON data here. So all I need to do is select this column, I click on the column, and then on the right side I start getting recommendations. And look, currently we have 3,400 rows on the bottom there. If I select here, the machine learning suggestion, flatten the JSON array into new rows. Convert arrays in the cells here into new rows. If I select that, now we have 34,000 rows. We have 10 times more rows. So what the system did was it identified 10 objects inside every cell. It takes those 10 objects and pivots and makes 10 times more rows. So every one of those objects has its own row. So, okay, that's good. I like it, so I click Add. When you click Add, you add the step to the recipe. Okay, that's good. We still have an issue with this column here, because we can still see that there are some JSON objects here. Okay? There's multiple attributes here, attribute value pairs. So let me click again this column, and let's see what the recommendations are now. Now it's suggesting that we unnest this JSON object, and we take out all those 13 individual key value pairs. So there's 13 different things in there. and it will create a new column for each one of those key value pairs, okay? If I do that, the original column is on the left here in blue. The yellow ones are the new ones, done by machine learning as a suggestion. So there's a discount column, there's a due date column, freight, whatever, product key column. So basically we get new columns out of the JSON. Okay, I like it, I click add. Now we can get rid of the original JSON column because we already opened it, we already unnested it. So we can drop this. So I select it one more time. Now the recommendation is delete this column. We don't need it anymore. Okay, we deleted the original column. That's good. Almost done. But if we look at the order date here, we can see that there's an issue. So we can see there's clearly a date value here, date timestamp. However, the system is telling us that it's a string. Yes, but it would be better if it was a timestamp. Because if it's a timestamp, we can do time calculations later on against these values. There's a problem. There's a space UTC here in the end. There's a bit of string here in the end that is causing a confusion. All I need to do, let me show you again, is highlight with my mouse space UTC, and you can see it selects all of them, and then it gives recommendations. And one of them is to replace space UTC string with an empty string. And if we do that, the data type changes from string to date type. Yay! Let's add that to the recipe, and now this column is a date time column. Now we can do date operations and time operations against these values. There's one more like that. Shipping date. Let me fix the same thing for another column called shipping date. I cut out this substring that we don't like. And now it's also a date time column. I'll do one more thing. So we have now an order date and we have a shipping date. What if we could do some calculations while we transform the data? Let's make a derived value. Let's create a new step. I click new step, and then I create a new formula, and I start typing here in the formula date. And one option is date if. Aha! I can calculate the difference between two dates. What dates? Order date is the first date, and shipping date is the second date. And I'm interested in how many days is the difference between ordering a product and actually shipping a product. And now you can see, as I start playing with this function here, it creates a new column which contains a value. That value is a calculated value, how many days from ordering to shipping. That's good. Let's call it shipping delay. So later on we know what is the point of this value, shipping delay. So the first one has a 5-day shipping delay. Okay, I click add, and I add this to the recipe. Now it looks nice. So now I want to run this job, so I click literally run job on the top right here. And normally what you would have to do is you would have to create a data flow pipeline using Apache Beam programming. That can be a bit tedious because it involves Java or Python programming. Here with Dataprep, you can actually create data flow pipelines without any coding. This is the output of the job. We are not running the job yet. It suggests creating a CSV file. Well, I don't like that. I think it's better if we send the data to BigQuery. Then we can connect other systems to BigQuery easier. BigQuery is a data warehouse. So where in BigQuery you select a data set, maybe here. I want to create a new table, user group underscore demo table, and there we go, save settings. So now I basically told the system that if you run this job, create a new table in BigQuery and call it user group demo. Now I click run job, and now the magic happens. So basically, what happens now is that Dataprep, the service we are using now, is creating a DAG, directed acyclic graph, a graph definition for data flow. So it's basically programming data flow. It's creating the data flow pipeline for you. And you can find them in jobs. So now it's starting data flow. So you can see that we have this Taiwan user group flow here. It's transforming. It started a few seconds ago. And what we can do is that we go to data flow service. So let's go to data flow and see if there's a new pipeline starting now. Yes, there is. And look at this. This is the pipeline. The pipeline in data flow consists of several transformations. You remember that one of the things we did was unnesting the JSON. Another thing we did was removing a substring, space UTC. All these transformations here in data flow are those steps that we did together using the graphical user interface. But we don't have to code these transformations, either in Java or Python. The system is coding data flow for us automatically. It's even branching the data multiple times here and then collecting the results. And at the end of the show, what will happen is that it will then write the data into BigQuery. Okay, so it's creating and running a data flow pipeline automatically for us, and we didn't have to code anything. If we go to BigQuery, this is our data warehouse service. Let's take a look what we have here. So this is the data workshop dataset. Our table is not here yet. It will be here when data flow finishes. It will take about 5 to 7 minutes normally. Let me show you what it looks like normally. I know. So what is happening now is that data flow is running, right? But we didn't code data flow. Let me show you a data flow pipeline. So if you don't use Dataprep, if you want, you can of course create your data flow pipelines manually by coding it yourself. If you do that, it looks something like this. So here's one pipeline that I coded myself manually, and I was sweating, I was crying. So basically, here's an example of a data flow pipeline. It's not very complicated. It just handles some streaming data from PubSub. It calculates some averages, minimum, average, maximum, and it writes then. It does some windowing and aggregation, and it writes the results into BigQuery. So very simple pipeline, but I had to code all of this by hand. Yes, ultimately I figured out how to do it, but now with Dataprep we don't have to. It's doing it automatically. So that's now running. While it's running, we can wait for it to finish. We can take some questions. I just want to show you that soon it will be done. Any questions? So data flow, Dataprep, anything else related to Google? Any questions? Yes?
Can I import data from Markku HDFS or other systems?
Yeah, you can. You can definitely. You may, depending on where your data is currently, you may need to do some data movement jobs. So there are different source options for the data, but some people are using, for example, Apache Airflow now to schedule these kind of data movement jobs. So it's becoming popular to use Airflow to move data from, like Airflow can detect if you have new data somewhere, let's say in the old system. Yes, there's new data. It starts a job to move the data somewhere else, and maybe then you can kick off Dataprep. So Airflow is becoming popular as a scheduler for these kind of data movement tasks. And maybe as part of that data movement overall design, then you have Dataprep to then clean the data, use data flow and put it to a BigQuery. But if your data is there in Hadoop currently, we have different options in Dataprep to actually ingest the data. So it supports things like Avro format, for example. But it depends on your use case. But sometimes you may need to convert the format first. But we support multiple different format types. Let me see how it's doing in the meanwhile. Just give me a second. I think the pipeline has finished. See, everything is green. Well, not yet. Still running. Okay. Time for more questions.
You were showing one data set.
Yeah.
In this tool, can we use multiple at the same time? Or you suggest
Yeah. Yeah, actually it's a good idea to use multiple. So in this particular demo I have only one source file. It's a complex source file because it's an array of JSON objects nested inside each other. So that's the complexity there. I have another kind of demo prototype which has 2 or 3 different files and I merge them together. I do a lookup. So kind of like a foreign key lookup. Like this value in this data set is actually the same as that key in that other data set. And then it can, for example, do a join. So because BigQuery likes wide columns and sparse data. So rather than having 2 tables and then you look up with the foreign key, you can do that. It's better in BigQuery if you put everything in one table and it's a really wide format. And it's okay if some values are missing. It's a sparse table. So yes, short answer, yes.
So how about if you want to do the IoT streaming integrated with the
Yeah, that one is a code. So currently Dataprep doesn't support streaming. So Dataprep supports batch. If you want to do streaming, which I do quite often with my IoT toys, then it's here. This one actually is a streaming pipeline for IoT. It's a sensor pipeline. And some of you may have seen my building yesterday, if you were at the event. So this is that pipeline that collects the sensor readings from my smart building. Temperature, humidity, air quality, etc. And gets them from IoT core, pops up, and then writes them into BigQuery. So for that streaming purpose, you still have to write it by hand today. Maybe in the future Dataprep will support streaming, I don't know. Let's see again, has it finished? Give me a second, yes. So now see, there's a green tick mark everywhere. I think data flow is done. And now when we go to BigQuery and we refresh, there should be, yes, a user group demo table in BigQuery. So this is what Dataprep and Dataflow wrote for us. That's the schema. And if you look at the preview of the data in this table, we can